session we're going to learn about the quantization of audio. But before we start our today's session, let us revise what are the things that we have studied in the previous session. In the previous session we studied about the analog audio signal, digital audio signal, and how analog signal is been converted to a digital signal, and the vice versa, how digital signal is been converted to analog signal. Now in today's session we are going to study about the quantization of audio, like how the video is being quantized. Now quantization is a process to assign a discrete value from a range of possible values to each sample. Number of sample or ranges of values are dependent on the number of bits used to represent each sample. Now quantization result is stepped waveform resembling the source signal. Further, the quantization error or noise is the difference between the sample and the value assigned to it, is known as the quantization error or the noise. Further, with reference to the signal to noise ratio, which is SNR, signal to ratio refers to the signal quality versus the quantization error. Higher the signal to noise ratio, better the voice quality. Now what do you mean by this particular thing? In a sense, see, this is with reference to the video or audio things that we use in day-to-day life. If at all the mic that I am using is not being properly connected to the system or not being properly connected to the mobile device, neither I can record the voice clearly nor you can hear the voice clearly. The second thing, the major thing that is being used over here is with reference to the Bluetooth devices that we use. The Bluetooth device nowadays, it comes with airtight or air pack type of sensors, wherein you will be hearing only the sound that you have played. There will be no much noise around you, and you will not be able to listen to any of the noises around yours. For example, like you are listening to an audio and somebody is calling you, so you might not be able to hear to that particular calling. Why? Because you have been connected to the sound in such a way that the quality of sound is being improved, and the quality to which the sound is being hearing to you and the noise surrounded by you is totally different. Now, how? Another example is with reference to the Bluetooth device by which you speak. With reference to the Bluetooth device, when you are connected to the Bluetooth device and you are speaking on Bluetooth device, then you may not be able to hear any of the noise. In the same Bluetooth device, if you are speaking on a Bluetooth while traveling on a two-wheeler, with reference to the air coming in the opposite direction, there is the possibility of creating errors. So instead of uniform quantization, non-uniform quantization is used as commanding. Now, commanding is a process of distorting the analog signal in controlled way by compressing large value at the source, then expanding at receiving and before quantization takes place. Now what do you mean by this? As soon as the voice is being generated, now the voice which is being generated will be like, see, I am speaking, you are able to hear the voice clearly, and if at all the fan is this has been done with reference to the commanding process. What it does, the process of distorting analog signal in a controlled way. These signals will be controlled and will be recorded in a clear clarity way. So that's only the reason. See, if at all if you have listened to any of the audio sounds with reference to 128 and with reference to 320, what is the difference? The difference is in the quality of voice that you are able to hear and the modes by which it reduces and increases the sound. So this is a major thing. Now the next one is with reference to the transmission of audio, how the audio is being transmitted. See, the way I am speaking and the way you video, you might not be sitting in a closed environment where you are watching or seeing this particular video things. Now, the way I am transmitting this information to you depends on the receiver and the sender. Now what it does, with reference to the transmission of audio, analog signal should be converted to digital signal and digital signal should be converted to analog signals. Now how it will be done? This will be done with reference to the modulation and demodulation. The process of modulation and demodulation will convert the analog signal to digital signal and digital signal to the analog signal. So what it says over here, in order to send the sample digital sound or audio over the wire, that is to transmit the digital audio, it first to be recovered as analog signal. See, the transmission that happens is in analog form, so that no of the packet will be what you call as lost. Okay, the most important thing is that you should not lose any of the packets in between the transmission. If at all, if I am speaking like if at all the transmission is in analog format, you might be able to listen the maximum type of the signal. Now what it does, the transmission will always be done in analog format. And the receiver and sender send the analog signal will be converted from the analog process is called as demodulation. Now what is PCM demodulation? PCM demodulator reads each sample value, then apply the analog filter to suppress energy outside the expected frequency range and output the analog signal as output, which can be used to transmit or translate the digital signal over the network. What is PCM? PCM stands for pulse code modulation. Okay. Now this is what you call as a pictorial representation of the modulation and demodulation of the what you call as voice and audio signals. Now how the signals are being transmitted is been shown in this particular diagram. Now this is with reference to the amplitude and this is with reference to the time. Here the digital data is being given as an input, wherein the connected samples and low pass filter, which is the pulse code modulation decoder, will convert this particular digital signal into the analog signal. In the previous slide we have seen how the analog signal was converted to the digital signal with the help of PCM, with the help of modulator and demodulator. We will be converting these particular what you call as signals either from digital to analog or from analog to digital signals. Now the next one is with reference to the musical instrument digital interface. Now what do you mean by this? This is a protocol that enables computer, synthesizer, keyboards and other musical devices to communicate with each other. If at all, if you have seen any of the musical instruments, there you can see every of the keystroke will be having of noise or creating of music. Whatever the stroke that you have taken has its own notes of creating the sound wave, which our ears can hear. So what it says over here, MIDI, which is musical instrument digital interface, is a protocol that enables computer, synthesizers, keyboards and other musical devices to communicate with each other. So what is the setup? MIDI sensor. Okay, in the diagram you can see the particular thing. This is the one. It is been connected to the in. MIDI out of sequencer is connected to MIDI of in. See this one of synthesizer and through to each of the additional sound modules. Now what is the working for this particular thing? During recording, the keyboard equips understand I'm giving this particular example, sorry, is the keystroke that you press when recording a piano or when recording a guitar, the strings that you move. Also with reference to the modulation and demodulation of sounds in a DJ, how the sound is modulated there and how one particular track is being put on repeat with reference to working. During recording, the keyboard equipped synthesizer used to send MIDI message to sequencer which records them. During playback, messages are sent out from the sequencer to the sound module and synthesizer which will play back the music. This is how the things will happen. Like see, the DJ will be moving this and some of the tracks will be like replayed again so that and such that the sounds looks very efficient for you. Okay. Now the next one is with reference to MIDI data format, which is the information traveling through the hardware is encoded in MIDI data format. The encoding includes note information like beginning of note, frequency and sound volume up to 128 notes. The MIDI data format is all digital. The data are grouped into MIDI messages which will in return produces a wave of sound. Each MIDI message communicates one musical event between machines. An event might be pressing a key, moving a slider controller, setting switch and adjusting foot pedals. It can be anything. Now 10 minutes of music encoded in MIDI data format is about 20 or you can say 200 kilobytes of data. Okay, comparing against the CD audio. Now further with reference to the quantization of audio, quantization is a process to assign a discrete value from a range of possible values to each sample. Further, number of samples or ranges of values are dependent on the number of bits used to represent each of the sample. Further, quantization results in step wave. For that there will be a cover song, for that there will be a remix song, for that there will be a Punjabi remix or Haryana remix or XYZ type of remix songs. But the actual source remains the same. That is what we call as quantization of the audio. The actual source remains the same, but the sound, what we call as the sound modulation and sound wave propagation will be different for that particular thing. If at all that particular song is with reference to the cover song, the music will be very slow. With reference to the remix, additional music will be added to that particular thing. So this is how the things will be working. Now noise. This is with reference to the signal wave propagation. This is transmission. Okay. This was with reference to the today's session. I hope you understood something from today's session. If at all you have any doubt with reference to today's session, please ping me at rahmat_ali2u@yahoo.com, or sooner or later we can have a doubt clarification session. Until then, take care. See you in the next class.